So welcome everyone. Thank you very much for attending this presentation by Ismail Çendik, who is a 3D artist. He's going to be talking about basically modeling for VR, and the most important aspect of that being how you optimize these models for these platforms. Platforms which, for example, are hubs, Altspace or Vrchat. They have different restrictions, but they all, they all have some restriction, as well as some hardware considerations. Not every device can run everything. So Ismail is an artist that I've known for several years now. I guess Ismail, we met maybe 4 years ago.
Yeah, probably in
yeah.
2016. Yeah.
Yeah, and we've worked together on some projects. Been happy to have Ismail's support on the 3D side, getting me assets for some of the VR projects I've done for some companies here in Turkey, and he's also done a lot of training. Because it's important to be able to have practical experience rather than just some theoretical education for students at Koç University, where I'm a researcher and I also do trainings for VR. And so Ismail has given trainings for the students of Koç University, as well as I'm sure other places. But I'm very happy to invite Ismail to share his perspectives and his experience with us. So Ismail's got a presentation. So you can do Q&A, I think, throughout it. If that's right, Ismail. You don't mind if people ask questions?
Yeah,
kind of during?
Of course. It's not a problem.
So thank you very much, Ismail, for coming. I turn it over to you. Please take us away.
Okay, thank you, Michael. Today we are going to, as Michael mentioned, today we are going to talk about how to optimize your 3D assets for VR. So let's get started. Okay, so we should know the basics of the computer graphics, which is like meshes. Meshes are the basically shapes that contains information. A mesh contains vertices, faces, edges, UVs, face normals, and materials, etc. This is the basic of the computer graphics. So here we are. We have some example for the meshes. You are seeing a teapot, which is like a primitive object since 70s. We have Uta teapot. We have an axe in here, which is simple meshes combined together like cylinders and cubes. We have a bed in here, which is also an example, a good example for mesh. Okay, so those are the meshes. Meshes are basic. Meshes are shapes. So we have textures. So what is textures? Textures are textures, literally. Simply, textures are 2D images that contains visual information. So we have examples for textures. Like we have a chocolate mesh in the left side and the texture version of it. So if you want to give color or make something look concrete, you have to use textures. So we have a cookie in here, we have a sandwich, and UVs. UVs are basically the way you must have to texture your object. UVs are the 2D planes that contains UV space information for texturing. And UV island determines which faces are aligned on texture. So you are seeing a basic checkerboard cube in here, and this is the UV map of it. So if you want to texture an object, you must have UVs in a basic way. So we have Ezio from Assassin's Creed 2. You can see its face, its topology, its mesh in here, and the UV is in the right corner, in the ground, in the below. Okay, so we have a knight in here, which
Ismail, sorry, could you, on the previous slide, there's a center here. There's the normal and the maps. Can you? Yeah. And they look very similar to texture. What's going on here?
We have normal maps, specular maps, and color maps. There are different types of textures. Simply, a normal map is just a texture which looks like a blue most of the time, that defines the light reflection on the shapes. So yeah, basically it is. You can see the mesh version of it and the normal mapped version of it. You can see cloth foldings in here, like details, ornaments. So if you would like to create another layer of depth for the lighting, you should use normal maps. Okay, that's it, basically.
But they're the same thing as a texture, basically. They have UVs that
Yeah,
are...
of course.
Okay.
Yeah. Okay, we have a night in here, which is textured, and you can see its UVs in here. So, as I mentioned before, UVs are the flattened versions of the 3D meshes. So you can see it's here in here, which is here, like, you know, etc. Okay, so what is face normals? I have experienced too many people, I have seen too many people experiencing face normal problems and issues. Like I have mesh in here, but I can't see it, like these kinds of things. Face normals are orientation of the faces. If a face is orientating backwards, that means you can only see that face from the opposite side. We have an example in here, a good example in here. We have a simple sphere, and we are not able to see, can you guys see my cursor?
Yeah, we see it. Yep.
Okay, so we see these faces are invisible because they are orientating backwards. To understand which faces are orientating where, you can see the blue sticks in here. I mean, they are the orientation of the face normals. Okay, so what is a material? Materials are used to define the appearance of a metal. It's literally basic. Not too many things. I mean, materials are material. Okay, we have an iron fluor material in here, which is like rusty and, you know, some detailed. And we have a wood material in here. These assets from the Unity asset store, surfaces package, I have used it a while ago and it works really good. Although the texture sizes are too big, but you can optimize them. We will talk about them later. Okay, so
Ismail, can you how do textures and materials relate to one another?
Materials are basically the type of surfaces which you are plugging your textures onto them. Like you have a normal map texture, you have a specular map texture, you have base color texture, you are plugging them into the materials. So a texture is not going to work unless you don't have a material. So material is a must in this case.
So material is just like the package of textures and how they relate to one another?
No. Textures are textures, materials are materials. Materials are defining the version, I mean, the materials are defining how surfaces will look like in according to textures that you are providing. So you are providing textures to your material, and it says how to render to your GPU. Okay, any questions from here?
No, I think that's fine. But if anybody does have questions, you don't hesitate. Yeah, this is all the beginner stuff that that Ismail is covering quickly, but definitely people can ask any questions here about it. Yeah, there's some questions in the chat, but I think the community's responding to the.
Okay.
So no problem. You can go ahead, Ismail.
Okay. So we have platforms and devices. Of course, devices have their own limitations, and the platforms have their own limitations. We have AltSpace VR, Vrchat, and Mozilla Hubs as our platforms, and we have HTC Vive, Oculus Quest 2, and Oculus Quest as our devices, as you all know. So, of course, each of them has their own specific limitations. Let's talk about Mozilla Hubs before. Mozilla Hubs are using Spoke as an editor for Mozilla Hubs application. Spoke is working on web platforms as Mozilla Hubs do. So Spoke is the editor of the Mozilla Hubs, which is working on web platforms. And there are, of course, some limitations with Spoke too, but most of them I have experienced back in a while. Is the most hardest of them is Spoke wants you to have lesser than quarter case of VRAM, which is really I am challenged with in the before, because a VRAM is different thing. It's a video RAM, and I have never challenged with that, but that's the one of the interesting stuff in here. And because of because of the Mozilla hubs that are using web platforms, they have this limitation. I believe.
I can say a bit more about that. So this is a limitation for like iPhone 4. So this is a really old limitation. With Quest, you can do 1.5 million triangles.
Mm-hmm.
Approximately. You can do 1 gig of VRAM. But at the end of the day, those are the two kind of key things that you'll end up limiting your scene. So over 1 million, but less than 1.5 million triangles. And then the VRAM, it simply just doesn't work on Quest when it's more than a gig.
Yeah. But Mozilla Hubs literally optimized for web platforms, which is maybe understandable when it comes to these limitations. But of course, yeah.
So this is just because this is a platform that's meant to be accessible on all these different hardware. So it's not necessarily a platform hard limit. It's a recommendation because they're suggesting that you need to work with the lowest level hardware platforms that they want to support.
Which is iPhone 4, just that era roughly.
So Altspace VR. Altspace VR is using Unity as an editor for Altspace World. Many of you guys probably already used Altspace. One of the most interesting thing is the Altspace VR's 10 megabytes of a template limitation. I mean, I wasn't able to mean that. I mean, I didn't understand what's going on there, but they have a limitation like this. And your Altspace worlds should have lesser than 100 megabytes of data at the end because of the opening and downloading stuff from the server. So we have Vrchat. As Altspace does, Vrchat is using Unity as an editor too. I have really find insightful and interesting that Vrchat is like limiting you and recommending you 5 triangles for each avatar. I mean, that was a solid thing. I have never saw any I would say any equivalents.
That's for the Quest. Because they inside of Vrchat, they tell you that avatars, like they give you a visual indicator whether this is for Quest or whether this is for PC, and same thing for Worlds. So these recommendations again are focusing on trying to be supportive of people who are on Quest, which is like with hubs. The recommendations are there for the weakest hardware user rather than necessarily the best experience. But there's a lot of people in our community, actually, Ismail, I'll tell you, that they're actually going to be building for Vrchat worlds, and they have to choose, do they want the best quality or the best experience? Most of them almost certainly are going to want the best experience. So this 5,000 triangle limitation for each avatar is something that they have to be aware of, particularly if they're going to make their own avatars.
Okay, so roughly we do know, or at least we have some ideas about what our limitations is. So let's talk about optimization of a thing. Okay, so step 0 of the optimization process is know what you are dealing with. So what the object is, what is the scale of it? Can you interact with it, or what's the importance of the asset in the whole world? So let's start it from the 0. What is it? Is it a car? Is it a couch? Is it a prop? Or is it a hero prop or non-hero prop? I mean, solid thing. Scale of the asset. I mean, is it too big like a building, or is it just small like a dice, etc., or like a plate? Interaction level of the asset is more likely considered. It must be considered when it comes to optimization of thing. If you can hold it in your hand, which means you can also see it from more closer. So you should optimize assets in according to those. The importance of the asset is most important when it comes to think. Is it a hero prop? Is it just a decoration? That's all the questions. So, so we are now what we are dealing with, what we are working on. And there are approaches and there are methods that we can use to optimize an asset. One is retopology, two is decimating, three is remeshing, and four, merging vertices. Let's get started with retopology. As you can see, retopology is the best way to optimize an asset, but it's really hard and professionally required solution. Retopology is basically to use an existing mesh as a skeleton and redraw top of that. I have created retopology stuff back in my career too many times. I mean, it's literally painful and professionally required. We have a short model in here, which has like too many hundreds of the, maybe thousands of polygons, but we have a retopologized, a redrawed version of it. As you can see in here, in the next example, we have a decimated like short, or you know, what do you name it? We have a decimated version of it. We have a non-decimated version of it. It is really millions of polygons. And we are going to retopologize it with a good topology flow, I mean, edge flow, etc. So you can even lower it when you have a good topology while having the same look.
And how do you retopologize? What is the work aspect of that?
Yeah, we are going to that like in next slide. Retopology is a method that you are doing by your hand. So it is why retopology requires profession. Keeping polygons consistent, I mean polygon flows, I mean for each faces, the distance for each faces, redrawing surface from the scratch, it is really a process. So I have a quote on this. If you want to torture someone, ask him to retopole an asset. Me at a random date at a random Discord server. So I'm pretty active in the designers community, and when it comes to retopology, most people like afraid of retopology because it is really time consuming and torturing. Okay, so there are plenty of retopology tools you can use. I am a Blender user myself. I'm using Blender to create almost everything for me. And there are, of course, useful tools for the retopology stuff. One is a 3D Code. 3D Code is a standalone software that is mostly about overall mesh stuff. Like you can draw here from scratch, you can sculpt it, you can texture it, you can UV. 3D Code is a good application for this. Topogon is meant to be, literally meaningful in here because Topogon is literally, it is just used in topology because it is a topology software. To mention Anvil in here, most of you shouldn't ever heard that because it is on Steam and it is not literally public. Anvil has some good retopology tools that is working automated, and Maya has some retopology, has some useful retopology tools like QuadRaw tool. So there are, of course, other softwares and other stuff you can retopology, but this is my recommendations to you.
I mean, Ismail, so in this example, you have this really high quality mesh that you get from somebody, you know, this original shirt.
Mm-hmm.
Is there ever a time where this is beneficial to start with this high poly mesh and then to retopologize? I mean, does it help you, or would you like, is it easier just to start from scratch? Like, what would be the case where that it would be right to go to plan to retopologize something?
Actually, retopology, as I mentioned, is the best way almost every time because you are creating it from the scratch, not the machine, not the computer. So if you are using some animated models like characters, like a shirt in this example, if it's going to be animated, retopology is a consideration, of course.
But what I mean is, so you have this high quality shirt here, right?
Yeah.
Why? And so are you just looking at it and then with your eye making the model? Do you
No.
need that high quality mesh in this process at all?
Most of the times, yes, because retopology is an approach to an existing thing. Like you have it as a skeleton, and you are redrawing the surfaces on the exact meshes.
Okay, so
Christoph,
rather than just like someone showed you a picture of the shirt and you just modeled it from zero, it's easier for you, the artist, to have this high quality mesh to compare it to.
in here we are talking about optimizing and existing things. So yes, in this case. Yeah, it's not the same, Christoph. Remeshing and retopology is different thing. I will be talking about that later. Okay, is there any questions until here?
I think you can go on.
Yeah. Okay, there is another approach when it comes to optimization, decimating. Decimating is like literally eating faces on the existing surfaces. Like we have this in here, which is going to be a sculpture or something, and it has plenty of polygons that we don't want to have. So you are just decimating it, which breaks its topology most of the time, and etc. But as I mentioned, it's the best. It's one of the most working approach. So let's imagine you have this sculpture in here, which is 100 million, which is 500,000 polygons, and we have decimated versions of it. 100K of triangles looks good. 10K looks good either. Even 1K looks good. Imagine you are going to texture it, but 100 polygons is not good, basically. Okay. Yeah, decimation is an algorithm, which means it doesn't have to work good every time. There are disadvantages on decimating surfaces, like decimating is eating your UVs. It's cutting your UVs. So if you have a textured asset, decimation might be painful later. So you can see there's a decimated version of this teeth and mouth thing, which one of them is made by hand, which is called retopology, and one is for decimated. Triangles looks same. Triangle counts, but yeah.
But the decimated one was done in like 1/1000th the amount of time.
Sorry?
But the decimation one was done much faster than the one on the retopologized one, right?
Yeah, like milliseconds, because it's an algorithm that works. Okay.
And there's good algorithms and bad algorithms.
Yeah, I will mention Zbrush in here. I will underline Zbrush. Personally, most of the time, I have to consider decimation as an approach, but I'm happy. So there are some tools for decimation. Blender has a decimation modifier inside coming, which works good all time. For Zbrush Decimation Master, Zbrush has a plugin that's called Decimation Master. That's the best tool I have ever used for the decimating. Zbrush is a software, standalone sculpting software, which has most of the things inside of it, like almost everything. The Mesh Lab is good to tell about in here. Mesh Lab is most of the time used by experiencers. Scientist people. So they are using Mesh Lab most of the time. Yeah. Any questions about the optimizations? Questions about decimating in here? Sorry.
So when you say that the decimation can break the UV, I mean that's true with with retopology. You have to remap the UVs, right? So
Yes.
it's kind of the same in both cases. Like whatever the UV was on the original mesh, you're going to have to remap that, right? Is that really time consuming? Is that difficult to do?
Most of the time, yes, because you are literally destroying what is existent in the topology and recreating stuff from the scratch.
Some tools, as you said in the previous slide, do that for you, and with various degrees of success.
Yeah.
They keep the UVs. Yeah.
Yeah. Zbrush Decimation Master is literally to be mentioned in here. It is really good.
There's also some kind of like enterprise level decimation tools. So Simplygon is
Instaload and stuff like that. To mention about decimation when it comes to mind, Unreal Engine has an inside LOD generator, which the approach is same with decimation. It is really useful and good and to be considered when it comes to decimating an existing mesh. It is really good and works good most of the time.
It's in the engine.
Yeah, it's in the engine.
Oh wow! And Unity doesn't have anything like that, right? That you know.
Yeah, it doesn't have internally.
Mm-hmm.
Probably worth explaining what LOD is.
Oh yeah.
Yes, but it's the same algorithm with decimation. So if I have short time for create something that needs to be good, I'm exporting the thing to the Unreal Engine and decimating it with LOD generator and exporting it.
But what LOD means, that's level of detail, right?
Yeah, it's completely a different thing, but we are talking about an approach in here.
But for those in the audience who maybe don't know what LOD, what it means is it's usually when you get close to an object, you have actually different versions of the same model, right? Different levels of detail.
Yeah.
So closer, yeah.
LODs are as Michael mentioned, are the different versions of the assets. So let's imagine you have a sculpture which you can literally come near of it. A sculpture is huge. You should see it from like miles away. So you are creating LOD versions of it. Like for the first LOD, which is the one you are literally closer it. Let's imagine it has 500 Ks of triangles, and in LOD1, which you are seeing it from like 50 meters away, it has like 100 polygons, and LOD2, which you are seeing from like a half kilometer away, like 500 kilometers away, it has like 1,000 triangles, like etc. So that's the level of detail.
Michael, you are still mute.
My microphone is muted. I didn't understand.
No, Michael's microphone is muted.
Okay.
Sorry, that was my fault. Yeah. So I was saying that Antonio has a question in the chat about decimation, and specifically whether there's any difference between having quads or triangles here for that.
Okay, good question. A good question. Decimation algorithms triangulates your objects automatically most of the time, like 90% of the time. So you cannot select to have. So most of the time you cannot select to choose to have quads or triangles, because decimation algorithms literally converting them to triangles. And of course, there is differences between quads and triangles when it comes to animation most of the time. What's Adam?
what's the add-on? There's an add-on for Blender that generates LODs and exports. Oh, that's something that to Squash. That's a question that Squash was talking about, an add-on for Blender, and Christoph was asking what the name of it was.
Okay, so I'm continuing. Okay, so remeshing. Remeshing is one of the fastest approach on optimizing stuff when it's usage combined with decimation. So what Christoph, as far as I know, Christoph is mentioned before instant meshes is what we are talking about remeshing. So remeshing may be confused about retopology. I mean, these two can be confused, but remeshing is an algorithm which is created by the computer, and retopology is what you are doing with your hand. Okay, so simply remeshing is an algorithm that works with fields of meshes, redrawing surfaces automatically on existing surfaces. So let's say we have this object in here, and you need to remesh it. So the algorithm is going to remesh it and gives you this result. So you have this sculpture for example, and this is the remeshed version of it.
And so that differs from decimation. I see that these are squares, these are quads in the end result of this.
Yeah. Remeshing algorithms is based on quads, so polygons, quad polygons. Remeshing is not interfered with triangles. It is not creating triangles most of the time. Okay, as I mentioned before, remeshing is not same with retopology. Remeshing is an algorithm that works on existing surfaces. Retopology is draw something from nothing, basing on the mesh. So remeshing is a technique and retopo is an approach, although results might look same each other. Okay, so in the right one, this is a retopologized one by hand, by a person, by a human. And the left one is a remeshed version. It is remeshed, basically. So you can see the topology flow is different, like the edge flows, like which is better is of course the topology.
But so retopology and decimation seem conceptually similar. What makes decimation and remeshing? Sorry, what makes remeshing and decimation different?
Most of the time, you need to remesh in higher qualities, like millions of polygons, to have identical thing with what you have created, because remesh algorithms is working with fields of meshes that voxel. Most of them is voxel based. So you are going to remesh something with millions of polygons, then decimating it. That's an approach. Okay, there are plenty of literally too many algorithms in the market in the world. But there are some I have recommend to everyone. One of the instant meshes is what Christoph before talked about. Instant meshes is really good and lightweight application. You are simply dragging and dropping your object there, and it's literally recreates the thing. And Zbrush is, as I mentioned before, Zbrush has almost every tool inside of it. And of course, it has a Z-remesher inside. And there is one to be mentioned for an add-on for Blender is Exosite Quad Remesher. I have used this most of the times, and it literally creates two good things for an add-on for Blender. Remeshing is much faster than retopology, of course, because remeshing is an algorithm that meshing does.
Okay, so Blender is free. Are these add-ons like Exosite Quad Remesher also free?
No, that's not a good way for the Blender. Blender is a free and almost covers everything that you may need inside of it, even video editing. But some handy add-ons like Exosite Quadrimesher and UV Pack Master, etc. I'm using bunch of them. Can't remember which one of them. These add-ons are most likely to be paid, like $10, like $50, etc. Yeah, that's it. Okay, so we have another approach in here. Merging vertices. Merging vertices is a simple method to snap vertices that near each other and eliminating surfaces that doesn't affect overall silhouette. So let's say you have this corner in your building, before, I mean, underneath the wall, and it has 812 polygons. Why 800 polygons in here? Because we have these cross intersections in here, which we don't need them. And we are just literally eliminating them, which doesn't affect the silhouette. And we get this result, which is 56 polygons, which is a huge difference. Merging vertices is something you will go for. I mean, you will go for that, but not always an option. There is one to be mentioned in here as of our approach are finished. You need to final touch your objects. Like let's imagine you have this haunted house looking structure in your scene. You are only seeing this from this angle, what we are seeing right now. You should delete faces and everything that you are not seeing. So let's say you have backside of this building, which you will never saw. You are just simply deleting the faces that you are never saw, and that's a recovery. Let's say you have this car, which again you are only seeing from this angle. You have to delete the tires on the left, like interior, like stuff like that. Okay, so
when you do this, you also should go to the texture files and delete that part of the texture?
Yeah, not delete, just paint with black, or I mean, you don't always have to do something while going this way, but painting them with black or some similar color in the texture would work fine because of the texture encoding. I will come for that.
Okay, and but that like just makes does that make the texture file smaller? If well, I guess if it's compressed, is that what happens? Like if there's a lot of it that's black, it's just takes up less memory in the texture file?
Basically, textures are indexed by colors. Less colors most of the time means lesser file size. Sorry, lesser file size. So if you are going to paint those areas with black, which means lesser colors will be used on the file, and you get lesser file sizes. Okay. So optimization step 2. What we call optimization is not only including mesh optimization, but textures, lighting, and materials, of course. Yet mesh optimization collapses almost 40% of the process. So in here, we are going to talking about texture optimization and texture things oriented with texture optimization. Okay, starting texture optimizations is of course followed by texture atlases. A texture atlas is basically an image file that includes a bunch of things combined in one texture. So let's say you have this steampunk, maybe you have this ship in your scene, which has an individual texture file for each, like sails, iron things, like compressors in here. You are going to combine all of them in just one. And in the image 2, example 2, we have a whole huge city in just one texture. That's basically texture atlases. Okay, so we have an example from Assassin's Creed 2. Texture atlases is a must when optimizing textures. So the Assassin's Creed team has created an only texture file for details of the buildings, like beams in here, like structural elements, like wooden parts in here, etc. So what you are seeing green highlighted on the screen is just using one texture, which is a huge coverage from the everything. Okay. Any question about here? Because this is kind of important.
No, that's pretty. So that's better than having a texture for each building or each type of building. Like you just have these different. How many texture atlases do you think, looking at it, do you think cover these buildings in this scene?
I do believe. I mean, it is hard to say something, but I do believe they are used some vertex blending shaders in here. Like I assume they've used 10 or 12 different textures and just vertex painted the areas with some deformations in here. Like in here, you have these destructed, I mean, how to say, peeled look. You have just vertex shader it, vertex painting them. That's an approach.
Okay. I think vertex painting is something else we're probably not going to get to in this one.
Yeah, of course. Yeah. Yes, David is right in the chat. And yes, we have this question. Why I have to combine textures into one? Answer is simply, this is how machines work, how computers works. More files, meaning more individual data, is called by GPU, which result increase of draw costs and a significant impact on FPS, frames per second. This is not the this is not the texture atlas of the Minecraft itself, but Minecraft in the Minecraft binaries, Minecraft has this one, something like this. A texture atlas, almost everything in just one texture. Okay. So, file type is one of the most important thing on textures. Make sure you are compressing your project's textures and be sure about their bit depths. 8-bit depth per pixel would work fine for games and VR related stuff. There are bit depths like 8-bit depths, 24-bit depths. Bit depths are usually are the thing that is the scala of the colors. Like an 8-bit depth texture can only contain 8-bit depth of data. But if you are going to use 24, which is increasing the texture size, you will get more colors, more detailed colors. But 8-bit depths is always working fine for me, of course. I mean, in my 6 years of the career, I have never used 24-bit depth textures, which I didn't lose anything. For compressing texture stuff, I can recommend XenConvert. XenConvert is a batch image processor, which is I'm always trying to use. It literally processes hundreds of textures in like minutes, hundreds of image files, not textures. Textures are image files, so yeah. We have a PNG gauntlet. We have a standalone software called PNG gauntlet, and yes, this is the logo of that, a gauntlet. PNG gauntlet takes your image and compresses it, basically.
But this doesn't do the atlas, right? The atlas is, how do you create that big, massive atlas?
It is most of the time I'm creating a texture canvas in Photoshop and putting stuff in here, putting stuff in the Photoshop, or I'm using some external tools like there is one for the Substance Painter Texture Atlas Combiner. I'm using this kind of stuff, but you can create texture atlases in any image editing application like Photoshop, GIMP, etc. And we have TinyPNG. TinyPNG is a web solution which you are uploading your texture or image file there, and it compresses it, like most of the time 70%, it compresses the size and gives you back. Yeah, that's it. Any questions about texture optimization?
No, I think David provided some, some of the same topics you talked about the importance of having a large texture atlas and reducing the number of draw calls as you described.
Yeah. Okay, so let's go for the lighting optimization. Lighting optimization is a step 3 of our optimization process. First of all, there are mostly two types of lights: a dynamic, aka real-time lights, and static lights. A dynamic lights is lights that are real-time, that they are moving, not static. Like a flashlight in here is an example. A torch, maybe. A car's like brakes, maybe. I don't know what's the name of them. And static lights is static lights, like a light bulb, like a static light. That's it. And we have a third version of the light type, which is mixed lighting. Mixed light, basically. Mixed lights are acting like real time, but they are literally static lights with baking. Basically, that's it. Okay, for the dynamic lights, the light has to be calculated at every frame, which causing also a huge impact on FPS. So be aware of using dynamic, aka real-time lights. So a computer has to compute every single frame with the dynamic lights. So it is really expensive when it comes to optimization. For the static lights, the light will be calculated for once and will be based on additional texture files called light maps. So you also have to compress those light maps. Baking static lighting is a headache for me because it takes too much time.
Are light maps like texture files, but for the world?
Yes, for the world. And light maps are multiplying light in the existing scene. That's basically that. Okay.
I would have here a question.
Sure.
When you have these dynamic lights, let's say there's a city with some searchlights who are always repetitive. So they are in general moving, but they are not really controlled by the user. So it's somehow a loop of what's darkness and then brightness and darkness and brightness. Could you compress this in a kind of loopish compression that this part of the picture you never cross by a character, you can't approach it closer, so you only have here a moving light, but it's still not real time? Is this helpful for you of designing moving lights in a scene?
If your mention in here is like something like sun, which is a dynamic light, of course you can't. If you have a day-night cycle, you can't do anything with light maps unless the baked lights. So is this an answer for your question? I might have not understand it really.
Well, I think what Martin was asking is, and I wonder if the example you gave with the sun is relevant here, because if you know where the light's going to be, and the light's going to keep repeating these positions, could you have like a light animation? Rather than have to calculate it, could you pre-calculate this series of different light positions?
A light map is calculated every single possibility where light directs, where light hits. So a light map would be fine for this. I mean,
But
basically that.
You would need to make multiple light maps on each position and then animate them over a timeline. I'm not too sure game engines can support that today.
Yeah, I've seen something like that with day-night cycles where there's like 16, you know, it's like a very low poly, and you're kind of just transitioning between like these 16 different, maybe not even light maps, but like just maybe
Texture.
shader changes, or yeah, like just something's changing the color of everything.
Okay.
Maybe that's a way, Martin, that you could do something like that, where instead of it being light, maybe the shader for those objects that are under the light react differently.
It's I just wanted to say for hubs, you know, where you get really low limits because it's kind of running web. Pretty much the best way to make a nice hubs environment is to bake the lights in, because lights are really kill your performance, and they're not very good in hubs. So baking, yeah, I agree, is like as a nightmare. I'm discovering it's quite hard to do it. It's a lot of work. But if you get a nice light baked environment from Sketchfab, which is what I do, it's worth it, because you get something that looks like there's nice lighting and you get an atmosphere and all that kind of stuff. So it's very important for if the room is static, you know, that's your way to go for an optimizing.
Yeah, I would echo that for almost any VR project, you know, that I've worked on. You know, you have to, I think you have to bake it.
Yeah.
So
could you elaborate a little bit what takes time in that baking, like manual allocation of lights, or is just processing time?
The process of the light map baking is calculating the light hits and bounces and writing them into textures. So what takes time is computing and calculating of the process of this. I have like two weeks ago, I have light mapped one of my scenes for like 30 hours, more than one day. Happy.
Yeah, what you can do, what you normally do before you finalize everything is you have a low resolution light map. So it's like having a low resolution, you know, image is effectively what it is. And you can do that faster, and that's where you're just kind of getting a basic sense of the lighting conditions. But that's just for developing and testing, so that you don't spend an hour waiting. You know, you go out to have lunch and come back and hope that it's done rendering the light map. You know, you do it in like 2-3 minutes. But it's not for the final version. It's just for quick testing.
While the development process continues, everyone does a lower resolution of the light map to test and see everything. Then, if they are sure everything is good, they will create a more and highly detailed and high time-consuming version of that. So that's, yeah.
But the word baking is still confusing me a little bit, because I have a light designer, cinematographer background, and I have once get a chance to look into an Unity project with so-called baked lighting, and it was before the technique of ray tracing. I got the project, I opened it, and I found the so-called visual lights who were to see for the visitor of the scene. So there were like some light fluorescent bars and so on and so on. But then all the reflections, as it was before ray tracing, this was caused by an invisible light. So they placed a light here and a light there. They made it invisible. So I who had the project, I was able to switch on all these invisible lights that I can somehow see them. And then, of course, the room was there. There was the certain lights, and the lights represented a bouncing. But in general, it's still live calculated somehow. Even when everyone called it, this surface is not reflecting. I put there a light, and then you see it changes through the light what I put there. So it's baked. It can't be changed by a live circle of the sun. But still somehow I don't get somehow this termina baked, as it's still okay, it's a fixed light, it's not moving, it's invisible, it makes an effect on the asset or on the wall, on the structure, on the texture, but it's somehow.
And you record, the baking process is to record what that live light is emitting into the texture. So then you can take all the lights out the scene, but it looks exactly the same as if the lights are there. So you need the lights in the Unity scene in order to do a real-time lighting, but then you capture them, you know, bake them into the texture, so then you can take all the lights out and it looks the same.
Yeah,
in Unity, you have these. Sorry, Ismail, go ahead.
Additionally, with David's, they say which I'm completely agreeing with. Are you sure that your lights is baked lighting? By any chance, could they be mixed version, a mixed lighting?
I just got this project delivered by a monstrous zip file, and I looked at without any kind of knowledge of lighting inside of Unity, but I looked at it with my knowledge from the real world. So I realized pretty quickly, okay, this world is not capable of reflecting. This world is not capable of this modern, so hyped factor of the ray tracing. And I found all these hidden lights, so I understood somehow how they create the mood and the scene. But I have not spoken with anyone who was involved in the creation of this process of the project. So I don't know if it's mixed or baked.
Yeah, you can check what Ismail is asking, which I was going to ask the same thing, is that in Unity, at least, when you place a light, certain lights like spotlights can be dynamic, but other lights like area lights, for example, that they cannot be. They don't let you be that. You know, you can change these lights to being baked lighting, you know, static lighting. It's a setting. And some of them don't let you change it, but some you can change it. You can choose whether it's baked or whether it's dynamic. But if it's dynamic and you go to bake your lighting, those lights won't contribute to that.
Yeah. So one of the most lighting expensive works I have created a while ago is the game, our upcoming VR title that we have worked on as Freya Gameworks is Buried Alive: The Annihilation VR. Buried Alive is coming live on store like in 19 of these months. I will post link, Steam store link in chatting here. A minute. In Buried Alive: The Annihilation, we have we have a day-night cycle. Everything must be. Yeah, it is actually, even talking about lighting of Buried Alive is really hard because it is too complex when it comes to lighting in this. Buried Alive is a zombie shooter game, VR zombie shooter game that as Freya Gameworks we have worked on environment design, lighting design, etc. Basically, Buried Alive has a day-night cycle, flashlights and lanterns and stuff like that, and all of the lighting is called every frame, so they are dynamic lighting. So optimizing this project was a nightmare level challenge for us, as an example. Okay, so any other possible questions about?
Yeah, I have a question about the dynamic lighting. So if you have fewer polygons, does that mean you can use more? It's easier to use dynamic lighting. How can you increase how much dynamic lighting you can use? If, for example, that was something that you really needed.
It is. It is mostly the quality of shadows, type of shadows, and your quality of the light maps. It is basically the quality of the real time that you are using. Like, is it you can change it to calculate on every frame or every 2 on frame, like calculate, not calculate, calculate, not calculate, etc. So you can change the shadow resolution, shadow quality, and this kind of things in real-time lighting, so you can make them more optimized for most of the devices.
Can I have a question?
Of course.
Ismail, about baked lighting. You mentioned you baked it for 36 hours. What was the size of that, and does this size affect performance?
Size most of the times, of course, affects it, but my scene was an open world 1 kilometer square map, so it was not easy that much for a computer to compute. But yes, size does affect. Light map count, light maps in your scene affects. Light map counts of your scene affects. Your lighting baking quality affects. Actually, everything affects the process, basically. Okay, so more quality, more waiting time, which is really understandable.
So, but for this 1 square kilometer project, this map, what you had to do, are you able to have, are you working with techniques, there's a character and the character has a certain amount of view, let's say he looks depth of field, sharp, 10 meters, 20 meters, then it gets less resolution. So on the square kilometer map, I only have to calculate for the viewing point of the character, like in this, recently everywhere is this end display for the virtual production. Everyone is talking about virtual production and they're emulating where the camera looks, and they are giving on this displays the high resolution where actually the camera is looking, and the rest is just for an environmental light. So are you working in the game engine in the same way, that you are giving them a depth of field and the range what they are seeing, and then you are only calculating that?
As of the project was open world. Sorry, from I assume some sound coming from Nick's mic. Michael, can you? Okay. As of the project was open world, which means player can go to the everywhere except the boundaries of 100 meters from every side of the map. It was literally fine detailed everywhere. So the distribution of the quality was same, was linear everywhere. That was your question.
Well, but you were using like LOD systems, right? So
of course,
dynamic lighting at distance was less expensive than it was closer to the character, right? Because the objects that were casting shadows were simpler.
Actually, there are two kind of things that when it comes to in the perspective of Unity, you can choose your objects getting influenced by light maps or your light props. So for the LOD zeros, I mean the finest version of the every asset, I have created light map. But for the objects more than LOD1 and for the smaller objects, I have created light props, which is taking lighting data from the lighting props. So with this way you are optimizing it. And of course, when it comes to open world stuff, you have to do these followings, like ultra LOD, like ultra LODs for the buildings. Like even if there is a box, it should stay there for building. Imposters and billboarding systems is most important. Imposters are basically textures that are standing there for there are cards and has a texture. So from looking really backwards, you only see 2 polygons of card which has the texture of the object. That's a way. And there is, of course, other ways to optimize an open world scene.
Yeah. So this is more about optimizing the scene rather than particular models.
Of course, of course.
Yeah, yeah.
Yeah, but optimizing objects is a must, of course. Okay. So as of the step 4, we are going to talking about materials, but not talking about too many of the materials. Materials are basically using shaders, which are already fundamentals of the platforms. Like if you are using Altspace VR, if you are using Vrchat, if you are using Mozilla Hubs, their shader systems are literally optimized. So you don't have to know too many things about this. But if you are creating your own custom shaders, the silver key of custom shader optimization is to have always cheap math. Shaders may cause huge impact on frames per second loss, but you can optimize them with having having less math and cheap math. Yeah, that's for the shaders.
But if you're, so a shader, for people who don't know what a shader is, it's kind of it's a script. It's actually code that describes what to do with that object, right? With what the material is.
Shaders define how objects will react to the light. So basically you are coding surfaces, literally surfaces.
But if you're, as you're saying, if you use the standard ones that come with Unreal or Unity, then that isn't a particular, those are already very optimized, so you don't need to do much with them. But if you're having performance issues, you might consider trying a different shader that's simpler.
Most of the times, yes, but standard shaders and mobile shaders in Unity is literally well optimized for end user products. So I do not hesitate to use default shaders, most of these default shaders coming with Unity. But there are some exceptions like specular calculations. You shouldn't have to using specular calculations, this kind of things. Okay, so let's roll with what's heavy for what. So we know the basic concepts of what we have. Does that mean it will work every time? No, answer is no. Optimization is literally bounded on millions of parameters. Even if you know those parameters, this is computers. Nothing is predictable, but you always can have an idea. Optimization is literally structured on trial and error and completely experimental in much cases. Okay, let's go with the examples. Question, I have a crate which isn't a hero prop and has 20K polygons. Is this too much? What are you doing? It's a simple cube which shouldn't have more polygons than 200. Let's imagine you have this box and it has 24Ks of polygons, which is too much. And you shouldn't spend that many things on that if it is not a hero prop. In talking aspect of this create, which is a simple thing. Question, I have this car which isn't a hero prop and has 180 polygons. Hey, that looks good, but we are not in 1999. Like, a modern video card can of course handle a couple hundred more polygons for this. So let's say you have this car which is super optimized and maybe looks good, but in many cases, quality comes before the optimization. So for this one, you can of course spend some much hundreds of polygons, which is not going to be a problem.
If it's a flight simulator, I guess it makes sense to keep it at that level of detail.
Yeah, as we talked in this step zero, we have talked about what is this, what we are dealing with. So you should follow those rules in optimizing things. Okay. Another question. I created this wine list for my brand new Altspace world. Has 2,000 polygons and will be interactable. Okay. I assume you will duplicate this like 20 times. Glass shader may be heavy for the purpose. In order to people interact with those, polygons is okay for this one. Translucent, meaning transparent shaders are most of the time is expensive. So you shouldn't too much using these shaders. But when it comes to stuff like glasses, you don't have that many like chances to go with. So yeah, that's it basically. I have this M4A4, which is an animated hero prop with 18,000 polygons. Polygon count is acceptable and model fits its purpose. So this weapon looks good, looks detailed, even considering an animated one, like reloading, like firing, etc. It looks good, and the polygon count is okay, but you should consider textures and other things, of course.
But this is okay because it's close to the camera. That's what you,
Yeah.
that's what you mean, yeah.
Yeah, the animated hero prop is what should be underlined in here. Okay, as you can see, there are many ways to create and optimize a model for your project. You can take whichever way you choose to arrive your destination. Okay, that's the end of the presentation, I believe.
All right, well, thank you, Ismail. Thank you very much for going into as much detail as you did on everything. Are there any questions at the end of the presentation? Obviously, we got to ask some during it. I'm curious to know, like, when you showed Ismail a few slides ago, the glass, you know, the glasses, that, for example, some of us were in Venice VR's festival, which was in Vrchat, and we had these glasses and we could drink from them, and it changed the world. You know, it had like a shader effect. But I don't know that I've seen see-through glass, you know, very often in these platforms. And I guess it's, as you described, they're quite expensive.
Yeah, because of glass shaders are literally rendering the back of the surfaces, which is like another process for the camera, and which is rendering. Glass shaders are expensive to occasionally. For the world changing, I believe it was a post-processing effect or something like distorting the camera view. I'm not sure of that. I have never tried.
All right, great. Are there any final questions? Anything in the chat? Just some thank yous, it seems like. Yeah. So yeah, if anybody wants to reach out to Ismail,
Ismail.
that's his company. Oh, go ahead.
Yeah. So when do you anticipate like having automated optimization workflows available for content creators? Like, would it happen in 2021 or 2023? Like, when you just upload your scene, set up a like few hyperparameters, like point out the hero props and non-necessary props, and then basically run an algorithm which optimizes the work you just described.
For the point clouds, I have never tried what I do know what point cloud is, but I have never tried to optimize a point cloud or some sort of thing, so I don't know with that. But for your question, there are automated tools that optimizes your scene just like one click. Instalot for one of the most. Let me write that to the chat. Instalot is really good software that I'm using. I have used several times. It is fast approach to optimize your things, but it is not. It is only creating LODs, which is decimated versions of them. But you can, of course, use LOD1 or LOD2 as your LOD0. So yeah, there is an optimized version, optimized software solution for automated optimizing, whatever you call it.
But you still have to do these on a case-by-case basis. Is that, you know, it's not like you can do the whole scene that you built in Unity or Unreal or something. You can't just like press a button, set a maximum, you know, poly count, a maximum, you know, file size for the scene. You can't just press a button and optimize a whole scene.
Of course, and optimization is a profession, as I told before. Of course, there isn't a one-click solution for this, but you can do most of the tricks you can do. But it's a process and it's a profession required thing.
Yeah, I'm wondering what's behind your question, because I've seen something like this for AEC applications. So when HoloLens 1 came out, it had a really low polygon count limit and all this kind of stuff, and pretty much most of these VR AEC model viewing applications do some what I would call inline optimization. So you upload your Revit model, and then most of them do something where you have to upload it to the cloud. A cloud service like Simpligon does the optimization pass, and then seamlessly, the HoloLens downloads that version of it, 5 minutes later, 10 minutes later. So I've seen this kind of single, if you like, one of the lines of optimization is being done in these applications, but that's just for a single asset, which happens to be the thing you're going to walk around, right? But in a game, I think there's just too many variables, right, Ismail?
Yeah, as I mentioned,
these things you mentioned, yeah.
Yeah, it is completely bounded on millions of parameters that that we cannot even know what's them, like the user's computers, like etc. Like these many things.
I can share an example where some of the early photogrammetry stuff that I was doing, which I think we're starting to see more optimizations in some of these cloud photogrammetry platforms. But like in mine, I did it manually. And I had this statue, right, that you were going to see in VR. So it's like 11 meters tall. So of course, I don't need 500,000 polygons at the top half of it, because people can't see it that closely. So if I ran a decimation algorithm on it, it would decimate everything at the same distribution, which would mean that I still have too much detail at the top of it. So what I would do in Maya, I could select that section of it and decimate just the selected polygons. But that's something that I would have to, a one-click solution wouldn't know how I intend to use that model. Like in VR, people can't fly, they can only stand on the ground and they just can look up. Mm-hmm. So I think that's the biggest issue with, you can have a one-click, even for one big asset, you can have a single click that decimates it down to something much more manageable, but it's still not really optimized for purpose, because you're not reducing, like in my case, some of it I need higher quality than other parts of it, and I have to define that.
There are some, as far as I read, there are some progressive decimation approach are creating by researchers in this genre, in this industry. Zbrush has a painting solution for decimation master. You are painting which you are painting the zones, the areas of your asset to have more polygons, to consist more polygons than the entire asset. But it is not an automated thing. But I believe from beginning, where most of the triangles are spent, you can save those areas. But that's algorithm that doesn't know what you are doing. But progressive algorithms with deep learning can be built top of those, which is, I believe, already in action. Someone is creating kind of things.
Have you noticed, Ismail, in the last few years, has it gotten easier for you? Is there more automation in your workflow in just the last few years?
I have in my last few years, I have meet with the. I have no problem. I'm again muted.
Yeah, sorry. I meant to mute myself and I muted you by mistake. Sorry. Could you repeat the last few things you said?
In my past, in the past 2 years, I have met with the Insta LOD. Insta LOD helped me some of the time, but since 2017, I'm using Zbrush Decimation Master as my decimation tool. So I didn't have that many. I haven't encountered that many problems because I am already using the best one in the market, one of the best in the market, which is the Zbrush Decimation Master.
There is a question, actually. There's a question in the chat for you from Seher. So she's saying that we can, I'll read it out loud for those who are watching the video later. She says that she exports objects from Adobe Medium, which is a VR sculpting application, and she takes it into Blender or ZBrush to optimize. But she doesn't always succeed with that process, and so she sometimes just takes it directly back into Unity, and she just asks if you think FBX or OBJ is better.
File types most of the time doesn't have impact on your on what you are doing, because the mission of file types is to contain information, to have information on that. So there is, of course, I mean, FBX, which is Autodesk's Filmbox, is the best data type in the industry. It can carry lighting information, material information, mesh information, like animation information, rigging information, too many things, even textures on itself. But OBJ is not always carrying that many informations, unless vertex normals, face normals, faces, meshes, like this kind of things. So FBX is the best way to carry, and the best and the universal way to carry your assets, basically.
All right, there you go, Seher.
You are welcome.
All right. If there's no final questions and my cats don't take over the call, I think we'll finish it tonight. I think it's about time. So yeah, maybe the cats will. But I apologize for that. So I want to thank Ismail very much for your time and all of your preparation to give us this presentation. And then thank everybody who attended and asked questions and contributed to the discussion during the presentation. Thank you all very much.
Thank you all very much.
All right, then on that note, this ends this instance of Zero Events. Thank you all very much for coming and joining us in the XR crowd. If you want to learn more about our events, just follow us on LinkedIn or on our Discord. I'll post the Discord in the chat in just a moment. And see you all next time. Know that we have a few events upcoming, which are jam focused. And actually, hopefully, maybe you can apply some of Ismail's lessons, because we're going to learn how to upload worlds for Vrchat, for hubs, and for AltSpace. So starting on the 23rd, Saturday, we're going to have a jam for building worlds in Vrchat together. Everyone kind of learning how to do it. Then February 6th, hubs, and then 2 Saturdays later, I forget the date off the top of my head, we'll be doing the same thing for AltSpace. So be prepared to apply some of these optimization lessons. Thank you all very much, and I hope to see you everyone next time.
Cheers, Michael. Thanks, everybody.
Thank you.
Bye.
Teşekkürler İsmail.
Rica ederim.
Thank you.
See you all.
See you on the sessions.
See you. Bye bye.